So in our last video, we looked at solutions and intermolecular forces when we had a liquid and another liquid trying to mix together. Now in this video, we want to look at, well, what happens if we take a solid and add it to a liquid and try and make an observation about whether those things mix or not. Is it going to dissolve? Is it not going to dissolve? And can we explain that based upon this idea of intermolecular forces? Okay. So let's go ahead and look at, well, what happens if we take potassium chloride and we add it into water? Okay. Solid potassium chloride, we add it into water. We're going to think about what processes are going to happen when that happens. Okay. So I'm going to go ahead, I'm going to zoom in on the surface of potassium chloride. Okay, so we have solid potassium chloride. We're going to have potassium ions, and we're going to have chloride ions. Okay, and so if we're looking at kind of the solid surface that we would see of our potassium chloride, we'd see kind of alternating rows of these, right? And then it would continue to go backwards within our substance as it goes into the bulk of the solid. Okay. Now when we take this solid and we add it into water, if it dissolves, these molecules are going to break apart, right? They're going to break out, okay? And so if we get, for example, our chloride ion. So we have our chloride ion here, okay, and I zoomed in a little bit so we can see it a little bit better. We have our chloride ion. Well, when we add our chloride ion in our potassium ions into the water, they have to be attracted to the water in some way. Otherwise, it's not going to want to dissolve, like immiscible or miscible liquids that we just talked about in the previous video. If they're not attracted to each other, they're not going to mix. If there's no attractions here, they're not going to mix, right? So if we have our chloride ion, how would it be attracted to the water molecules? Well, if this is a negative charge, remember water's polar. Okay, so if water's polar, we'd see it would arrange itself where this is the partial negative side, this is the partial positive side. Our hydrogen atoms are going to be arranged facing our chloride ion because it's positive, right? And so we have this dipole existing for the water molecule, and we have an ion here. And so we would see each of these would be attracted to the water molecule there, okay? Well, this attraction is not any kind of intermolecular force that we've talked about, this idea of dipole-dipole attraction is hydrogen bonding, London dispersion, because now we have a dipole interacting with an ion. So we call this ion-dipole attractions, right? Just look at the name, ion with a dipole. That is a new intermolecular force that we can discuss, is this idea of how those things relate to each other. So now we have this attractive force between the polar water molecule and the chloride ion. And we'd see something similar for our potassium ion. It would just be opposite, right? If the potassium ion was here, this water molecule would be flipped around, and the oxygen side would be facing into our potassium ion, right? So it would look like this, surrounded by our water molecules, with the oxygen side facing our potassium ion. And we still have the same type of attraction being formed here, right? It would still be ion-dipole. We have the dipole of the water molecule attracting to the ions of the potassium and chloride ions, okay? And so now we have this attractive force here. Now, if we're looking at if something's going to dissolve or not dissolve, it has to do with the kind of relationships between this ion-dipole attractions, the attractions of the potassium chloride ions with each other, and the water molecules. And so we're going to talk about in class kind of the energetics of that, the energies that are involved with those specific steps or processes. But this gives us kind of a good introduction into what happens when we actually dissolve chloride or potassium ions. Okay? This process where an ion is surrounded by water molecules, okay, we call that hydration. Okay? And that's where we surround a solute with water. Okay, so they're surrounded by water molecules. Doesn't have to be an ion. It could be something like sugar, right? A polar molecule surrounded by water, right? If we wanted to make it more broad, we could call it solvation. Okay, and that's where we surround our solute by the solvent. Okay, in this case, our solvent is water, that would be hydration, and the ions are the solute, the thing being dissolved into the solvent. So we're going to talk about energies and how energies relate to whether something's going to dissolve, right? Whether it's soluble or whether it's insoluble. We're going to do that in class.